Hi everyone, Assalamualaikum. In this video, we are going to discuss extremum points using partial derivatives. Now, we look at example 3 from the previous semester papers. Find the critical points of fxy equals to 6x squared minus 2x cubed plus 3y squared plus 6xy and classify each point as a relative maximum, relative minimum or saddle point. Alright, to solve this question, first step, we need to find all the first and second partial derivatives. Okay? First partial derivatives means fx and fy, while second partial derivatives means fxx, fxy, and fyx, fyy, right? Alright, to find the first derivative, we differentiate from f equals to 6x squared minus 2x cubed plus 3y squared plus 6xy, right? Alright, from f here, we can find fx. Fx means partial derivative of f with respect to x. We treat x as a variable from f here. And at the same time, we treat y as a constant. Since we treat x as a variable, so to avoid error and easy to differentiate, we write variable x in different colors and we put at the back, right? Then we can find fx. When we differentiate 6x squared, x is a variable, we have 12x, okay? And then minus, when we differentiate 2x cubed, and x here is a variable, so we have 6x squared using power rule, okay? And then when we differentiate 3y squared, y is a constant. So constant times constant is constant. So means that we differentiate constant, okay? And when we differentiate constant, it equals to 0, alright? Alright, and then 6yx. Y here is a constant. So y times 6 is also constant, okay? Constant x, when we differentiate, we still have constant here, and then we differentiate x equals to 1. We just imagine, let's say we want to differentiate 12x. The answer equals to 12, right? Then we simplify, so we get fx equals to 12x minus 6x squared and then plus 6y, right? After that, we need to find fy. Fy means partial derivative of f with respect to y. From f here, we treat y as a variable and at the same time, we treat x as a constant, okay? Since we treat y as a variable, so to avoid error and easy to differentiate, we write y in different colors and we put variable y at the back, okay? Then we can find fy. When we differentiate 6x squared, x now is a constant. So x squared and then times 6 is also constant. When we differentiate constant, the answer equals to 0. Okay? And then minus. From here, we have 2x cubed and x is a constant. So 2x cubed is also constant. When we differentiate constant, the answer equals to 0. Okay? And then we have variable y here. We treat y as a variable. So when we differentiate 3y squared using power rule, we get 6y. Okay? And then from here, we have 6xy. X we treat as a constant. So times 6 is also constant. Means 6x is a constant. Constant y. Okay? If we differentiate 10y, let's say, the answer equals to 10. So if we differentiate constant y, the answer equals to constant. In this case, our constant equals to 6x. Alright? Then we simplify. So our fy equals to 6y plus 6x. Alright? Alright, from fx, we can find fxx and fxy. Okay? Fxx means partial derivative of fx with respect to x. We treat fx, from fx here, we treat x as a variable. So to avoid error and easy to differentiate, we can write variable y in different colors. And then we put variable x at the back here. Okay? Then we can find fxx. Okay? Since we treat x as a variable, so when we differentiate 12x, the answer equals to 12. And when we differentiate 6x squared, the answer equals to 12x using power rule. And then we still have minus sign here. And then when we differentiate 6y, y we treat as a constant. So times 6 is also constant. When we differentiate any constant, the answer equals to 0. So we have plus 0 here. But no need to write. Okay? Alright, then we need to find fxy. Okay? From fx here, we treat y as a variable. Before that, fxy means partial derivative of fx with respect to y. We treat variable y as a variable. And at the same time, we treat x as a constant. Okay? So when we differentiate with respect to y, so we get fxy. Okay? And then when we differentiate 12x, x we treat as a constant. So differentiate constant, we get 0. No need to write. And then x here, we treat as a constant. So 6x squared is also constant. So when we differentiate constant, it also 0. So no need to write. Okay? And then when we differentiate 6y, y is a variable. When we differentiate 6y with respect to y, the answer equals to 6. Okay, 6 here comes from here. Okay, 12x and 6x squared when we differentiate equals to 0. Alright, so we get fxy equals to 6. Alright. Alright, from fy here, we can find fyx and fyy. Okay, fyx means partial derivative of fy with respect to x. From fy here, we treat x as a variable. Okay, and at the same time, we treat y as a constant. Since we treat x as a variable, so to avoid error and easy to differentiate, we can write variable x in different colors and we put at the back. Okay. Alright, then we can find fyx. Okay. When we differentiate 6y, now we treat y as a constant. So when we differentiate 6y, it is equals to 0. Okay, no need to write. And then when we differentiate 6x, x we treat as a variable. So when we differentiate 6x, the answer equals to 6. So 6 here comes from when we differentiate 6x here. Alright. Alright, after that, we can find fyy. Fyy means partial derivative of fy with respect to y. From fy here, we treat y as a variable. And at the same time, we treat x as a constant. Since we treat y as a variable, so we can write y in different colors. Okay? Alright, to find fyy, we differentiate from 6y here. Y is a variable, so we get 6 here. And then when we differentiate 6x, x is a constant. So 6x is also constant. So when we differentiate constant, the answer equals to 0. So we have plus 0 here, but no need to write. Okay? Alright. After that, we can check whether we differentiate the correct function. Okay? Or the correct answer. Okay? From here, we have fxy equals to 6. And from here, we have fyx equals to 6. So from here, we get fxy equals to fyx, okay, which is equals to 6. Okay, so we can use this concept, okay, to check if our derivative is correct. Okay, if we get fxy equals to fyx means our derivative here is correct. Okay. Right. Alright, after we find all the first and second partial derivative, we can continue with step 2. Step 2, we need to find the critical points when fx equals to 0 and fy equals to 0. Right? So from the previous slide, we get fx equals to 12x minus 6x squared plus 6y. Okay? Then we equate fx equals to 0. So when fx equals to 0, so we get 12x minus 6xy plus 6y equals to 0. From here, we can divide each term by 6. So we get 2x minus 6 minus x squared plus y equals to 0. 0 here, when we divide by 6, still equals to 0. Alright? And then we naming it as equation 1. Okay? And then from fy, from the previous slide, we get fy equals to 6y plus 6x. Okay? And then when we equate fy equals to 0, so we have 6y plus 6x equals to 0. Okay? When we divide each term by 6, so we get y plus x equals to 0. Okay? 0 divided by 6 still equals to 0. Okay? Then we can write y equals to negative x. Then we naming it as equation 2. Okay? Alright, after that we can solve two simultaneous equation, equation 1 and equation 2. Okay, let's say we use substitution method. We substitute equation 2 into equation 1. Okay, so from equation 1, we get 2x minus x squared plus y. So y here we replace by negative x. Okay, then we simplify 2x minus x equals to x, and then minus x squared equals to 0. Then we can factorize x here, and in bracket we get 1 minus x. So that when we expand, we get back x minus x squared equals to 0. Alright? And then from here, we have multiplication of function containing whatever x. Means that x here is equals to 0 or 1 minus x equals to 0. Okay, so from 1 minus x here, we can solve for x. So our x equals to 1. Okay, so now we find the values of x. Okay, critical point here means after find the values of x, we need to find the values of y and then write the answer in coordinate. Alright? Alright. Then we substitute x equals to the first value, which is 0, into equation 1 or 2. But we choose the easiest equation. Okay, let's say in equation 2. So from equation 2, we have y equals to negative x. So when x equals to 0, y equals to 0. Okay, 0 doesn't have negative or positive sign. Okay, we just put 0 here. Alright. After we substitute x equals to 0, then we substitute the second value of x, which is 1. So now we substitute x equals to 1 into equation 2. Okay? From 1 and 2, we choose equation 2 because equation 2 is more easier. Alright? So from equation 2, y equals to negative x. So when we replace 1 into whatever x here, so we get y equals to negative 1. Okay, then our critical points are when x equals to 0, from here y equals to 0. So our first critical point is 0, 0. Okay, and then from here x equals to 1, from here when x equals to 1, y equals to negative 1. And then the other critical point is 1. We write coordinate x first, 1, and then negative 1. Okay, so these are our critical points. Okay, we have 2 points for critical points. Alright. Alright, after we find all the critical points in step 2, then we can continue with step 3. Find D, where D equals to fxx times fyy minus fxy bracket squared. From the previous slide, we get fxx equals to 12 minus 12x and fyy equals to 6. Okay? And our fxy from the previous slide equals to 6. Okay? And then we substitute into this formula. Okay? So D equals to fxx, we replace by 12 minus 12x. And then times fyy. fyy equals to 6. And then minus fxy. fxy equals to 6. And then bracket squared. Okay? So we can expand 6 here inside bracket. So we get D equals to 72 minus 72x, and then from here minus 36. Then we can simplify this. So we get D equals to 36 minus 72x. Okay, this is our D. Alright. Alright, after find the function for D, then step 4, we use table of sign for D and fxx. Alright. We use this table in 4 columns. Okay. First column is critical point. Second column is D. Third column is fxx. And the last column is conclusion. Okay. From the previous slide, we get 2 critical points, which is 0, 0 and 1, negative 1. Okay. And we get D equals to 36 minus 72x from step 3. Okay. So from D here, we only have variable x. So we replace variable x, which is 0, into x here. So we get D equals to 36 minus 0 equals to 36. Okay. And then at critical point 1, 1, our D equals to 36 minus 72 times x. Now our x equals to 1. So we have 36 minus 72 equals to negative 36. Okay. And after that, we need to find the sign for fxx. Okay. fxx equals to 12 minus 12x. So now we replace x equals to 0 here. So we get 12 minus 0 equals to positive 12. So we put positive sign here. Okay. And then for the second critical point, okay, we substitute into fxx here. So we have 12 minus 12 times 1 means 12 minus 12. So equals to 0. Alright. Alright, to write the conclusion, okay, we can refer from here. Before that, our D at critical point 0, 0 equals to 36. 36 means positive. Okay. So now we have D equals to positive. So if D equals to positive, we need to check for fxx. Our fxx also positive. Okay. So when D positive and fxx positive, we get smile graph. Smile graph means minimum point. Okay, so we can write here. Okay, minimum point. Okay. Alright. Then for the second critical point, we have D equals to negative 36. So negative 36 here means negative sign. Okay. When we have D equals to negative, we no need to check the sign for fxx. When D equals to negative, so we can straightforward give a conclusion, which is saddle point. Alright. Alright, so from here, from this table, we can continue with step 5. Give the conclusion either maximum, minimum or saddle point. Okay, so from here, we have minimum point equals to 0, 0. Okay, and saddle point equals to 1, negative 1. So this is the final answer. Classify each point as a relative maximum, relative minimum, or saddle point. So this is our answer. Alright. Up to this point, we finish our syllabus in Calculus 2 for engineering students. Wish you good luck for your coming final. Try your best, okay? If you like this video, you can subscribe. Thank you for watching. Bye. Assalamualaikum. See you.